Hey, I'm Joe Burnett. I'd like to show you something I've been working on in StepRunner. So we've been building StepRunner for a while. We've built a couple steps with it. We've been kind of playing around with it. And there's a couple of things that are challenging to do, one of which is debugging. So when you run steps, you can chain them from one to the next. It would be nice to be able to inspect what's happening, like exactly what the state is and what the expressions are there, without necessarily knowing the internals of StepRunner, like as a user of steps. As an author of a step, also when that step is external, like a Golang binary, it would be nice to be able to step through that as well. So I've been trying to figure out how to solve this problem, and I've arrived at the idea of having a debugger built in to StepRunner. And I'm going to show you that. That's going to be the demo that I'm going to give you. So let me start by running an action. So actions are actually executed by a step. There's a step called action runner. It's a Golang binary. It uses the act project as a library to run the actual action. So we sort of use this other system. And so there's a lot about it that we don't necessarily, don't work with. It's kind of at an arm's distance from StepRunner. StepRunner delegates all the outputs to it, just says, hey, just run it. Just tell me whatever you got back and I'll just use it. Um, so debugging actions is challenging because it's this other binary. So I'm going to show you how you can debug it from the top to the bottom with this new Debug API. So for starters, let me show you this step. So the way that actions work is you just say action, the name of the action, and give it inputs. So instead of step, you say action, and the compiler expands that into a call to action runner. And it looks something like this when it's expanded. I expanded it already because I'm going to use a version of Action Runner that I've modified. Instead of running it in a container, I'm just running it in a Golang binary. And that's something that will be available when we start distributing steps as OCI images instead of, because it's just a way to get around binary, not checking binaries in. So what's important here is I'm running an action called YQ. It has YQ, runs it in a Docker container. And I'm going to say some sort of greeting, and then I'm going to pick that greeting up with a step, and I'm going to output it. All right, pretty straightforward. I'm going to do this through the gRPC API that StepRunner has built in. This is the normal way that steps are going to flow in from GitLab Runner into the execution environment is over gRPC. So when an ephemeral runner starts up, it's going to have this StepRunner uh, listening on this socket, and then we'll SSH in and we'll deliver the payload. To help like with testing, etc., we have a endpoint. We have a little utility called run. So you just can say run. And instead of running it locally, I've added this endpoint here. So I'm just going to run this example step, right? And it is going to pull down acts, put together a fake workflow, run the thing, capture the outputs. It actually happened pretty fast here. Um, and there it is, right? My step pulled the output, and you can see that there is the output here. But it's really noisy. That's really kind of ugly. Maybe I want to get in there and figure out what what is causing all this noise. So let's just say that I want to debug Action Runner, okay, which is what's producing these log lines here. It's a separate binary. So like when I run the steps, step runner says, okay, and it execs this other binary, gets the results back. So how do I bridge that gap? I'm going to start by using this new debug command here. And I point it to the same endpoint because it's an API. And I'm going to connect to this thing and I'm going to say, stop. Okay. Now, this step runner is now in a stop state. So I'm going to run this again, but this time we don't start rolling through. Instead, you see where we have stopped. Now here, um, this is a fake step that the run command made up. And it just it just said, you want to run example? Fine, I'll make up a step and run it for you. So this one's not really actually very interesting. So I'm going to step to the next step. I'm sorry, that's a lot of steps, but can't rename it now. Yeah, so here is the actual step that I defined, right? It says, okay, it's a sequence, you say hello actions, blah, blah, blah. Now this is the compiled version. This is the proto. So it's gonna download Action Runner now, and it's actually gonna like load the step.yaml file. So I'm gonna step to the next one. Here it's downloaded Action Runner. You can see here the directory that it loaded it from is right here. That's the hash of the version. Now, the next thing that's going to happen if I step to the next thing is it's actually going to exec Action Runner. Okay, it's going to run this binary here. This is the little modification that I made. I'm not running it in a Docker container. I'm distributing a binary. Okay. We'd like to do this with OCI images, not checking them into the repository, but for the moment, I just put it here. I would like to intercept that, and I would like to use delve to step through the binary instead. Okay, so instead of running Action Runner here, I would like to run this little program. So if I print this out, you can see that there's this super simple little bootstrapping program. All it does is it grabs your arguments here, and it just redirects them to a call to delve debug, and then execs it. You could do the same thing with a shell script like this. However, when you have JSON command line arguments, they mess up. Shells are not like the best thing for this. So that's why I used a Go binary. So I've built the Golang binary. You can see it's built here, step or Action Runner Del. And so instead of running the actual main Action Runner, I am going to override the first parameter of my command, and I'm going to set it to be instead delve Action Runner delve my special binary. Okay, so now you see that the code that we're about to exec is now changed. I kind of set in a little breakpoint. So there, and come over here. So I'm going to say step, right? Now, it did not actually jump to the next step breakpoint because it started delve. And delve is started in headless mode here. So I notice it printed out. Delve was like, hey, here I am. I'm ready to connect. So I can actually now say delve connect to this endpoint here. And I am connected to Action Runner. So let's see here. Let's look at Action Runner. Okay. Let's say maybe we want to stop here. So I'm going to say break at main go 25, continue. And now I can step into Action, right? I can get in here. I'm like through these, I've gone through the step runner into the Action Runner. I'm connected to it. It's going to collect from the action what the expected outputs are. So if I say print expected outputs, you can see that it outputs something result. That's how I knew how to pick that up with the expression. So I'm going to just kind of let this thing go. I'm just say continue, and notice that it actually runs the rest of the thing. Now it's exact this binary, so it's waiting for me to process to terminate before it pulls up the results from the file. So I'm just going to exit that and kill that headless server. So now I am back here in Step Runner, right? I finished this hello actions, and now I'm on print greeting. So theoretically, I have a greeting here. So let's see what I'm going to get, right? Because like I did this big heavyweight thing. Now I just want to kind of inspect the state, make sure I get this right. I could maybe like try a couple different iterations. So I'm going to evaluate this expression here. Okay, let's see what happens when I evaluate that. Hello actions. All right, so now I'm actually evaluating a ad hoc expression in the context of these steps in between steps, right? So like if, for example, I kept getting a problem where it was um, wrong, like if I said, if I kept saying results and my step and my workflow is failing because it's not finding results. I'm like, what is it? What is the thing I'm supposed to use? I can just get in here and keep trying until I find what I'm looking for, right? Like sometimes you just need to get in there and debug. So now I'm going to let this thing continue, and it finishes pretty much in the same way. So that's it. That's debugging the steps. It's not debugging the step runner, it's debugging the steps themselves because steps are just a program. Um, yeah. And it's a little proof of concept too, how you can shim, delve in there and with these execs. So it works as an experience. I'm putting this out as a merge request, so I'll link the merge request in this video across to each other so you can see the code, and hopefully it'll land soon. So thanks for watching.